Let's say a particle is at position x1 at time t1, and it moves in this direction and it gets at position x2 at time t2. So the velocity is a vector quantity, so the direction will be in that direction, but the magnitude will be, velocity is the difference between the distance between the two positions and divided by the time span. This can also be written as del x over del t, and if we talk about differential length, we can say when del t is very small, so if we talk about differential time difference, how the uh, position changes, we can say dx over dt in terms of calculus. X is often replaced by s, so it's also written as ds over dt. We will probably in this discussion use s more. Okay, so that's there. Now let's say the same another particle, same or another, whatever, at time t1, at this position its velocity is v1 and it's moving in this direction. At time t2 it reaches here and its velocity is v2. So the velocity is changing. In the previous case the velocity was constant, it was uniform velocity, but in this case it's changing. So the change in velocity divided by the change in time is called acceleration. It can be less, it can be negative as well, so then we call it deceleration or the negative acceleration, whatever it is. In that case the second velocity will be less than the first one. So this is again can be expressed like this, and in terms of calculus this can be expressed like this, dv over dt. So we can rewrite d dt, instead of v we can write s dt, so this becomes d square s dt square. So the second derivative of the position over time, the second derivative of position basically is acceleration. So that's there. Now if we go back to, these are the basic definitions of acceleration and velocity in terms of position. Now if we go back to the definition of acceleration, we can say acceleration is final velocity minus initial velocity over time. This is the basic definition of acceleration, and this can be rewritten as u plus at. This is a fundamental motion equation, one of the motion equations that I don't know whether it's fundamental, it's one of the motion equations that we often use, so we will state that. Then I can say that s is equal to, if we say u plus v over 2 that t, that means this is the initial velocity, this is the final velocity, and the average is the average velocity basically, times t is the distance. So this one can be rewritten. So what I am trying to do now is I am trying to get the relationship between s, a and t without the velocity, actually without the final velocity. So what I will do here, instead of writing v, I will write u plus at, and here it will still remain t. So this is becoming 2u plus at over 2 times t, or it is u plus half ut, plus half at square. This is another equation which we will often use, which is relating the distance traveled with initial velocity and time and acceleration. We don't need to know the final velocity. Again we will rewrite this one, and we will write this one, or again we will write this one, or we will rewrite this one, whatever. So this one, and now we are trying to relate an expression with velocities and distance without time, so we want to replace the time. So what we can do here is, we have this equation here which is v is equal to u plus at, which we can write v minus u over a. So t is replaced by velocity and acceleration, which we can do here. So v minus u over a, and this is becoming v square minus u square over 2a, or this is v square minus u square 2as. So v square is equal to u square plus 2as. This is our third equation of motion, which we often use, and this one is the acceleration, distance traveled, initial velocity, and final velocity. These the relation among these. And time, we have written this equation without any time element in the any time parameter in the in all the expressions. So this one is does not we don't need to know the final velocity. If we don't have the final velocity but we know other stuff, we can use this one. If we don't know the time but we know other stuff, we can use this one. Or these are the basic equations that we need to know before we start doing motion problems. So this is just an initial video. I will try doing some more I will try doing some problems basically afterwards.